Today we're going to talk about specific properties of isosceles and equilateral triangles. So before we start, we need to talk about some vocabulary to review for isosceles triangles. So let's draw a big isosceles triangle over here. And you remember in isosceles, at least two sides are the same. So let's mark, we'll just do two. These two sides are the same. If you remember from earlier sections, the sides that are congruent are called legs. So this is a leg, and this is a leg. Think about your own legs, right? Your legs are the same length. So imagine this is you. Right? There you are. There are your legs. This right here is called the base. This is from section 4.1, I believe. So now we talk about base angles. Well, base angles are the angles adjacent, which means next to the base. So here's the base. So here's a base angle. Here's a base angle. Well, you notice it kind of looks like your shoes. So you've got your legs and you got your shoes. That's right in here. Base angle, base angle. All right, and the vertex angle is the angle opposite of the base. So this right here is the vertex angle. Now, I think you've already done your activity, so you know that the base angles are equal, right? So those shoes are the same. So if you look down here, this is exactly what you did in your activity. If two sides of a triangle are congruent, then the angles opposite them are congruent. So opposite and opposite. Look, there's your base angles, there's your shoes. Right? Imagine this is you laying down. Here are your legs. Here are your shoes. You got to put arcs on those shoes, on those angles. So angle B is congruent to angle C. This is the base angle theorem. So whenever you see an isosceles triangle, you can use the base angle theorem. Or the converse of the base angle theorem. I also just call this base angle theorem. They go together. Notice if you see two shoes, you know you have two legs. If two angles are equal, then two opposite sides are equal. So AB is congruent to AC. So if you've got two equal angles, you have two equal sides. If you have two equal sides, then you have two equal angles. And then the other activity, part of the activity that you did, was equilateral and equiangular triangles. Right? I gave you two different equilateral triangles and you measured and you got these sides are the same. And then you measured the angles and you got these angles were the same and they were all 60. So equilateral and equiangular always go together. Equilateral gives you equiangular, equiangular gives you equilateral. Now we're going to apply these. So the first thing I notice is I've got two legs right here. And if I've got two legs, I've got two shoes or two base angles. So I'm going to mark my base angles. Base angle, base angle. Like, well, that doesn't really help. Okay, well, I know this is 70. And, oh, I see a linear pair right here. So a linear pair is 180 degrees, which means I need 110 degrees right here. Now, this is a little bit more helpful because now we're at least working in this triangle, so that's a good start. Well, oh, I see another pair of legs. So here's a pair of legs, which means I've got another pair of base angles. I'm going to use two arcs on these. So those two are equal. Well, if I'm just looking at this triangle, I've got 110 degrees, and then these two are equal. So I could call this y if I wanted. We could do this algebraically. Some of you probably can already do it in your head. So now I've got all three angles of a triangle. And I know that all three angles of a triangle have to equal 180. So now I can solve this. 2y plus 110 equals 180. So 2y equals 70. y equals 35. Some of you probably could have done that in your head without the algebra, and that's great. So we just use the base angle theorem, and we ended up with 2y here, and we got y is equal to 35. All right, now I want you to try these on your own. Look for the legs and the base angles. Pause this video here and give yourself a couple minutes to do these checkpoints. All right, so I see 2 legs, which means I've got 2 base angles opposite. Oh, those are equal. So 5x equals 75. Divide both sides by 5, and I get 15. Okay, well, so I know that's 75, and I know this is 75. Oh, and I know there's 180 degrees in a triangle. So 3y plus 75 plus 75 equals 180. 3y plus 150 equals 180. Subtract 150 and divide by 3. Now over here, this is your clue. You've got an equilateral triangle right here. So I would write in for all of those, I'm going to get a better pen for this. I'd write in 60, 60, 60. You're like, okay, well, how does that help me? Well, if you notice up here, we've got a line. These 3 angles are making a line. So I've got 70 and 60, which is 130, which means I need 50 more degrees here. Like, okay, well, we still haven't figured anything out. Well, notice I've got some legs. If I've got legs, I've got base angles. So I can put a y here, and now I've got the 3 angles of a triangle. Y plus 50 equals 180. 2y plus 50 equals 180. Subtract 50 from both sides. Divide both sides by 2. So now I got that. Over here, notice I have another isosceles triangle. I've got 2 legs. If I've got 2 legs, I've got 2 base angles. So mark those. We'll do a double on those. So that means this is 70. So I've got 70, 70. That's 140, which means I need 40 more degrees in my triangle. You don't have to show the algebra if you can do it in your head. All right, this is our last way to prove that triangles are congruent. So previously, we've used side, 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 angle, side, angle, and angle, angle, side. Today, we're learning one that's specific just for right triangles. So underline, star, heart, whatever you have to do. Right triangles. So if you look here, we've got a right angle that's equal. We've got a side, a pair of sides that are congruent, and another pair of sides that are congruent. Whoa, this looks like angle, side, side. And I thought we weren't allowed to use angle, side, side. We can only use side, angle, side. This is the exception when it's a right triangle. And in that case, we call it HL. Because if you look at the hypotenuses, hypoteni, I'm not sure how to pluralize that, are congruent, and one set of legs are congruent. All right, so BC is congruent to EF. That's your leg, your corresponding legs, and AC is congruent to DF, which is your corresponding hypotenuse. So triangle ABC is congruent to triangle DEF by HL. So we're going to add on to our little phrase today to remember HL. So if you remember previously, we said you can have SAS, right? You can have side angle side, but you can't be an ass Now we have an exception, unless you are right. All right, because right triangles can have angle side side, but we don't call it angle side side, we call it HL. Right, so hopefully that will help you remember you can use SAS and HL. Those are your two. So you can only use AS if it's a right triangle, but you call it HL. So we are going to skip this example up here and just go right to the checkpoint. I'm going to get you started on this. So we have to prove that this triangle is congruent to this triangle. So I think a good way to start is to draw them separately so you can really see what's going on. So we've got RTV and you've got SVT. All right, so mark our given. RV is congruent to ST, and RTV is a right angle, and SVT is a right angle. Okay, I already have that in my picture. We have to prove that these two triangles are congruent to each other. Okay, well, I've got an angle already, and I've got a side. One angle, one side. Well, that's not good enough. That's not enough information. So I need something else. Look for what they're sharing. Listen to this. RTV, SVT. Did you hear VT in both of them? They're sharing VT. All right, so let's see. That's another side. So I'm going to have you write the proof for this. I'm going to start it. So we've got RV is congruent to ST. Give me a reason. Then we've got TV is congruent to VT. Angle RTV and angle SVT are right angles. Now, in order to use the shortcut that you're going to use, you have to establish that these are right triangles. So we have to say triangle RTV and triangle SVT are right triangles. So now, let's see, we've got everything we need. Triangle RTV is congruent to triangle SVT. Take a moment, pause the video, see if you can list all the reasons for this, and then we will check our answers. So hopefully you found the first two given. Here's given, here's given. And they were sharing TV. Whenever they're sharing, it's reflexive. And then how do we know they're right triangles? Because they have right angles. So you can say because they have right angles, or you can say definition of right triangle. So now what do we have? It looks like we have angle side side, but we learned you can't use angle side side unless it's a right triangle. And what do you know? We established that these are right triangles. So this is HL.